Today's lesson is going to be talking about how we combine like terms. And during class, we're going to talk about our apples and our bananas and if they can be combined together or not. So with that being said, let's just jump right into some simple vocab here. Our essential question is, can I combine like terms and simplify? So I already have written down a variable. We know a variable is a letter that represents an unknown value. Let's talk about what like terms are. And our like terms are when we have the same variable, but we also have, big key word here is and, we have the same exponent. And we'll talk more about that with when we look at some examples. So those are what like terms are. Now let's talk about how do we know if they are simplified. And we know that we have simplified everything if we combine all like terms. And if we do that, then we know that our expression is in simplest form. So if you have everything combined that you can combine, then you know that you are in simplest form. So I do have quite a few examples here, but I've already got them set up and I don't think they'll take us very long to walk through. So I want to jump right into example 1, where it talks about 3a plus 5a. The reason I know that I can combine those or add those is they both have the same letter A, and those a's are both to the same power. So we just go ahead and we combine them. And we know that 3a's and 5a's would be 8a's. And you are done. That is in simplest form. There's nothing else to do. Let's look at example 2. Example 2 here, it says, and I apologize, it's a little dark. My next one is not as dark. It says 6b plus 4a minus 2b. And I'm going to tell you right now, we're going to go ahead and we're going to start to change these. I want everything written as addition. So we're going to take that 4a, we're going to leave it the same. We're going to change the subtract to add, and we're going to change the 2b to a negative 2b. We want to change all subtraction to addition. Now we need to identify what letters are the same. Well, if I look here, I see I have a 6b and a negative 2b. Those are the same letter, same exponent. They can be added together. 6 plus negative 2 is a 4b. I can't add anything to my 4a, so I just bring it down. And this is in simplest form. 4b plus 4a. Again, they cannot be combined. Why? Because they don't have the same letters and same exponents. Let's look at example. This one is interesting. It says 10y plus 4. What are you thinking? I hope you're thinking what I'm thinking, that you can't do anything. It's already what we would call simplified. And that's all you have to write. There is nothing we can do to this problem. It is in simplest form. They do not have the same letter, so we cannot combine them. Next. Excuse me. Here I have a 5r minus a 10r plus an 8rs. Again, the first thing we want to make sure that we're doing is we are changing all of our subtraction to add the opposite. That's step 1. Now let's try to identify what we think our like terms are. It would be our 5r and our negative 10r because they have the same letter that's to the same power. So 5r's plus negative 10r's is a negative 5r. We cannot combine anything with my 8rs, so we just bring my 8rs down. The negative 5 only has the letter R. The 8 has an R and an S. That means they cannot be combined because of the letter S there, and we are simplified. Let's look at example 5. Here on this example, we'll notice that we have all x's, but we have one x that has a different exponent. So the only two terms we can combine here are my 2x and my 3x. Why? Because they're the same letter, but they also have the same power. So 2x and 3x is 5x. Bring down your plus x squared and you are simplified. Now some people might write it, and this is perfectly fine. We could write it as an or. If you wanted to write it as x squared plus 5x, that's fine as well. Why? Commutative property of addition. And a lot of times you'll see it written more like the way that it's written in red, with your biggest exponent first. Both of those are correct. Let's look at our next example. This one has a lot of terms, and again, we want to make sure we change all that subtraction to add a negative. What number goes in front of an x if it's not written? We know it's the number 1, so I'm going to go ahead and put the number 1 in there. We also know with our minus 7, we're going to change it to add a negative 7. Now that we have the whole problem changed to addition, we want to find all these like terms. So I'm going to start with the 3. Does anything else just a plain number? And yes, we have the 3 and the negative 7. And so if we add those together, we get a negative 4. And I like to kind of cancel them out, knowing I'm done with those. I've already combined them. Now let's go to the next one. I have a negative 1x. Do you see anything else in the problem that has just an x? Well, the 5. So negative 1x plus 5x is going to be a 4x. And cross them out because you've combined those. And you only have one thing left, and that is your 2x squared. And so we just bring our 2x squared down. Again, if you would like to put that, change the order of that and write it as 2x squared plus 4x plus negative 4, that is the same thing. They're both correct answers. We just went ahead and put the biggest exponent first. Let's look at one more example, and we're actually going to pull in a property that we already learned earlier. And that property is the distributive property. So looking here, I hope you see we do have the distributive property. Again, I want us to change all of our subtraction to add a negative. And before we can do any combining of our like terms, we need to distribute first. I'm going to go ahead and put a 1 in front of these because we know that they mean 1. So 2 times 1 is 2x. Bring down your addition symbol, and 2 times 4 is 8. And you have taken that 2 and multiplied it by everything inside the parentheses. The 2 is only outside that first set of parentheses. We're going to bring down an addition symbol, and now we're going to take our 3 times everything in the second set of parentheses. So we have 3 times 1, which is 3x, plus, and we have 3 times negative 2, which is a negative 6. And now that we've gone through the distributive property, now is when we want to combine those like terms. So I could start with noticing I've got my 2x and my 3x, which would be 5x. So we've taken care of that. And last but not least, I have an 8 and a negative 6, which would combine as a positive 2. And you had 2 things to do on this one. We are reviewing the distributive property, and then once we distributed, we combine those like terms. And again, we'll talk about our apples, bananas, and our carrots in class. Have a good one.